But I'll tell you what we're going to see. We're going to see nothing at all here. All our solid would have gone up into the air as directly as gas. But what we'll see on the ordinary water ice is a pool of water, and it would take a long time before that water evaporated into the atmosphere. You're probably familiar with this dry ice if you've looked on TV or been to the theater or been to a pop concert. You see dry ice used to make a fog around the stage. So if we actually put some dry ice into a beaker of water like this, then we get a nice boiling effect. We get a fog going across the stage here, through our pop concert. And the reason for that is that the solid dry ice is evaporating and it's bringing up some water with it, and the water's making a fog just like an ordinary foggy day, but a rather cold fog, and it gives a nice sort of atmosphere to the whole thing. So let's look at our two piles which have been standing on our bench for a while. The solid carbon dioxide, the dry ice, is still completely dry on the bench. We've got less of it. The rest has gone up into the air. Our water ice, which has melted on the bench, we've now just got a puddle of water left. And that's obviously better if you don't want things to get wet. It'll keep things cold, but it won't make things wet. The other thing I want to talk about is a very important property of water and ice. What happens to an ice cube if you put it into your drink in order to cool it down? Does the ice float on the surface, or does it sink to the bottom?